Hi, good morning. So I have requested you for some suggestions now, but I didn't got any response from you. So it's okay. I can understand that you people are ready to listen the topic called biomolecules, right? So in the last during the last class itself, we have discussed. I have given some hints and some optically active, and I have given some and we have had a discussion about some basic part of optically active compounds, right? So okay, we will continue this chapter itself. So biomolecule is nothing but the molecules which are involved in the living organisms. I mean, the chemicals which will help us for the production of everything, what all we require. I mean, from starting from protein to every thing. I mean, lipids, carbohydrates. Nucleic acids, right? So everything what all our body requires for each and every movement of our proper movement of our body. So every thing we will study in case of what biomolecules, and here the case is different. What all the chemistry we study generally, that chemistry is different from this biochemistry, right? Or a biomolecule. Why? Because what are the study we do in chemistry, we just study about the other chemicals. But in biomolecules, what are the important drugs? What are the important chemicals are there for our body, for living organisms? We study about those only, and how the digestion, everything, what all the chemical reactions carrying out in our body. We will study all the things about what the biomolecule in the biomolecules, right? So this is general introduction, one we can say. And definitely, dear students, you don't worry about the notes and all. While mostly next month, or we don't know when our offline classes will start. Definitely, I will go through once again about these chapters, and then later I will like how in offline class I used to give the notes. And then the same way we will again going for the discussion. You don't worry about the notes. You just go through these video classes, try to understand the concept, right? Try to understand. If possible, you try to make your own notes. It is well and good enough for what understanding the concepts, one we can say, right? Try to refer other different books, so that if you come to know what is biomolecule and what are the concepts, then it will be helpful for you to go and read in depth, right? So that's why you just make a utilize of these classes. You don't worry about the notes and all, right? So here in your syllabus, first biomolecule after introduction, the next part is itself, that is carbohydrates, right? So carbohydrates are, we all know what are carbohydrates, right? What are carbohydrates and all? Carbohydrates may be defined as optically active polyhydroxy, optically active polyhydroxy aldehyde or ketone, right? This is nothing but the carbohydrates. Carbohydrates may be defined as optically active polyhydroxy aldehyde or ketone, right? So that's why I have explained during last class itself about the optically active compounds, right? So now we can come to know. So there are three things to understand over here in this concept. I mean, in this definition, one is optically active, other one is polyhydroxy aldehyde and ketone, already you know, right? So now see here, Optically active is nothing but what? So this compound, I mean these carbohydrates can rotate what? Plane polarized light. That is for sure. So that means optically active compounds are nothing but which rotates the plane polarized light in either direction. Maybe in clockwise direction, or it may be in anti-clockwise direction. No problem. But it should rotate the plane polarized light. If it is able to rotate the plane polarized light, then such compounds we call what? Optically active compound, right? So that means all the carbohydrates are optically active compounds. That is for sure one thing. Poly means many, hydroxy means OH groups. That means they are optically active and they have what? Polyhydroxy means many OH groups. Polyhydroxy is nothing but they are optically active. Polyhydroxy is nothing but many hydroxyl groups, right? Many such groups, I mean OH groups are present, right? These are the optically active compounds in which more number of hydroxy groups are present with aldehyde or ketone. Aldehyde, that is nothing but the CHO, and what about ketone? CH3, CO, CH3. This is ketone, right? So ketone, I mean this group in between. If they should have optical activity, and then they should have polyhydroxy, I mean many OH groups with aldehyde or ketone group. Understood? They must and should have optical activity, and then they should have more number of hydroxyl group with aldehyde or ketone, right? So such compounds, one we can call them as a carbohydrates. Some of the carbohydrates may be sweet in taste; those are called as sugars, right? So, so this is about the definition. Moving to the next part, I mean some characters of about this carbohydrate. Some of the carbohydrates, they are sweet in taste, right? They may be sweet. If the carbohydrates are sweet in taste, then those are called as sugars, right? So this is the next point one we can say. Some of the carbohydrates may be sweet in taste, and if they are having a sweet taste, then those are called as what? Commonly we call them as a sugars. That means sugars are also a carbohydrate. Sugar is also a what? Carbohydrate, one we can see, right? And then the most common sugar used in our homes is named as sucrose, right? Very important. So most common carbohydrate we used as a sugar in our home is what? Sucrose. It is a form of sucrose. So always, and this is one of the sweetest, and whereas sugar present in milk is called as a what? Lactose. The sugar present in milk is called as, or carbohydrate present in the milk, one we can call that as a lactose, right? So some of the carbohydrates are sweet in taste; those are called as sugars. Now, and most commonly used, what we use in our home as a sugar is nothing but the carbohydrate form called sucrose, and the sugar or the carbohydrate present in our milk, cow milk, that is nothing but the lactose, one we can say, right? Carbohydrates are also called as saccharides. Next point. Carbohydrates are also called as saccharides. Okay? So saccharide is nothing but it is a Greek word. Saccharide means simply a sugar. Right? So these are also, I mean, carbohydrates are also called as what? Saccharides. And these saccharides, I mean, it is a Greek word, and these saccharides are also called as sugars, right? So carbohydrate always when we can get in our roti also, right? So that's why here in our region, I mean in North Karnataka, we used to have a sugar diabetic, right? Why? Because we used to have more carbohydrates. So that's why at the age of 40 or 45, above 45, one we can get a disease called a diabetic, right? So this is about the introduction of about what carbohydrates. We had a definition as well as some what characters. Carbohydrates, if they are sweet in taste, then those are called as sugars. Commonly used sugar in our home, domestically what we use is sucrose, and the what carbohydrate present in our milk, I mean cow milk, that is nothing but the lactose, and these carbohydrates are also called as saccharides, which is a Greek word which means what, sugars, right? So next, classification of what, carbohydrates. We will see just the classification, and then later in the next class we discuss about the classification. There are around three classification types here. The first one is classification of carbohydrate based on hydrolysis. Classification of carbohydrates based on hydrolysis. This, I mean, this classification has asked once for 3 marks, right? So that's why each and every part, what all we have in our syllabus are very important, right? Sometimes they twist the question paper, right? So classification of carbohydrate based on hydrolysis. Hydrolysis means once we break the carbohydrate, if we get more units, I mean, only single unit we are getting, then those are called as monosaccharides. Already you know, right? Monosaccharide, oligosaccharide, disaccharide, and polysaccharide one we can say, right? So mono is nothing but if we hydrolyze monosaccharides type, I mean carbohydrates which are monosaccharides, a carbohydrate that cannot be hydrolyzed further. I mean, which these type, I mean, first type here we have 4 types, right? 4 types. First one is monosaccharide. Next one, oligosaccharide. Disaccharide and polysaccharides, right? So here we have these 3 categories. I mean mono, oligo, I mean 4 categories: mono, oligo, di, and polysaccharides. See, I will just give a hint, and in the next class we will go in detail. So mono means the name itself indicates it is a single, right? One we cannot hydrolyze it, right? So, such saccharides or such a carbohydrates are called as monosaccharides. So oligosaccharide means after hydrolyzing these, one we can get how many? I mean, 2 to 10 monosaccharides, saccharide units. We will go. We will discuss about the example also, right? So oligosaccharides are the type of carbohydrates. If we hydrolyze these type of, I mean, oligo type of saccharides or carbohydrates, then we will get 2 to 2 to 10 monosaccharide units. That means single units. If we hydrolyze such saccharides, I mean oligosaccharides, then nearly we will get 2 to 10 different I mean units of saccharide. So if they are able to give 2 to 10 monosaccharide, I mean single units, then such saccharides are called as oligosaccharides. And di is nothing but, you already know, after hydrolyzing, if it able to give 2 monomeric units, then those are called as what? Disaccharides. And poly means more than 10 one we can say, more than this, right? On hydrolysis, these type of carbohydrates are a class of carbohydrates. If we hydrolyze these, then we get more number of monosaccharide units. Such saccharides are called as what? Polysaccharides. So we will have a healthy discussion about these 4 types, and later we will discuss about the next part of classification based on reducing and non-reducing. What all those things we will discuss during the next class, right? This is all about today's class. In the next class, we will move with your syllabus, right? Thank you.